Yeah, just a bit more bench testing of the various circuits that I've been experimenting with. I had a sort of little bit of inspiration, but I'm not sure whether it's going to prove fruitful. But it might make the HV faking side simpler and keep it very accurately in step with the voltage. So if you imagine we have our 100 volt battery, or whatever, 120 volt battery in this case, my DC supply, and what if we just insert a isolated DC to DC converter into the system before the BCM fooler. Now you would use a single isolated converter here, but I only had two of the half the voltage required. So this is basically producing 50 volts isolated supply, and that is just added in series to the BCM fooler. So our fake battery, our 100 volt battery, is now 150 volts because we've just basically added a fake battery to it. So this is our fake battery. This is a 5 volt to 12 volt minus 12 plus 12 DC-DC converter for each of these. So I've got these two in series, so that gives me 48 volts total output. Isolated. It's only 1 watt, and this is just a load resistor to give the converter some stability. So basically we've just inserted a 50 volt battery, this is like another LTO pack in effect, into the system before the BCM fooler, and that makes our battery voltage appear to be 150 volts. So the bit we've got to do some work on now to keep it all in sync is the op amp in the system here, in the car here, in the MCM here, with that little op amp circuit there. Because if you think about it, plus 50% is okay at 100 volts, but it's not correct at any other voltages. So I need to adjust the op amp circuit there, or put a different circuit in there to add 50 volts rather than increasing the voltage by 50%. So that's a pretty straightforward problem to solve. So once I've done that, I'll do some more bench testing, and then it'll be ready to go. I mean, these DC to DC converters are pretty cheap. I think I've seen a 24 volt, minus 24 plus 24 volt one 12 volt input, which make it easy to use, controlled by a relay, for $2 or $3. So that would make that side very simple, and it's quite resilient as well. It provides plenty of current for the BCM fooler. We've got so much current, in fact. The BCM fooler only needs little current, but so that's why it's got a load resistor across it as well, just to keep it stable. So that's the idea at the minute. So a simple, very simple one chip solution, if you like, really, for the HV side, which is just to insert 48 or 50 volts into the system before the BCM fooler, and then just adapt the op amp to give us plus 50 volts simulated rather than plus 50%.